Welcome guys to our lecture on Java. Today we are going to look at generics. So under generics we want to look at the following topics. So in pre-generics code, generalized classes and interfaces and methods all used object references, especially collections API. It relied on object because object can basically accept anything. So what I mean is that if you wanted perhaps to have a method that is generic in pre-generics code, I'm just making an example, void generic, you'll have to say object. So obviously this method you can call it with any object. So you can say generics and you can pass in 9, this will work. You can pass a string, this will work. You can even pass the very same object that we are having here. Anything, it will work. Float f. You see that this method can accept anything. This is what they used in pre-generics code to cater for any type of object. And collections relied heavily on that as well. That is why after the introduction of generics in Java 5, collections framework was completely rewritten. It benefited quite a lot from generics. So this approach was cumbersome because you needed to do type checking. You can just imagine if your object or your method receives a generic object, generic type object. It means you don't know what object you're gonna receive. So you need to do type checking if maybe you're expecting different kinds of object, and based on that you want to perform some other functionalities. You will need to check, to do type checking to check is this the type I'm looking for. And also after that you needed to do type casting. You need to cast to that type that you are looking for. So you can just imagine all that was a bit of a cumbersome work that developer needed to do in pre-generics code. So generic is a class or interface that can work with more than one type. We saw that method that receives object as a parameter is generic, but the way it does its generic is not type safe, and it requires a lot more code to be written to make it generic as the word says. So Java 5 introduced generics, and after generics were added, collections framework, like I said, was completely rewritten, and it's the area of the Java language that benefited maximally from generics. So the convention is to use T and E for type parameters. So we can demo this with a class that can store any number. So what we can do is we can say we want this class to store any number. So what we can do, we can say T extends number that can store any number or work with any numbers. And what we can do here, we can say private TT, and we know that T is any number. So what we can do, we can write a method in here to work on T. Like maybe we can say public T, it returns T plus 1. I'm just making an example. So we can say return t plus 1. And what we can do now, we can have a constructor main that accept t as a parameter, and we initialize t. So then the reason for this not to work is because t is a number, so we need an implementation of it. So what we can then do is, instead of performing an arithmetic operation on it, we can what can we do? Because I'm not really interested in the plus. Okay, let's just say get and leave the arithmetic operation, because that's not what I want to demonstrate anyway. So what we can do, we can have main, and then here we can say integer main equals to new main, and we can pass 7 here. Then we can say sysout main.get. So before Java 7, you needed to specify the type here. So basically you needed to do this before Java 7. But then Java 7 removed this, and now this is inferred. Since we know that we have integer here, it's automatically integer here. It's inferred. So basically we can run this code now. This should work. We can put a double here, and this must be a double D. This will still work. We can put a float. This must be a float F. This will work. So you can see now that this our class is generic. We can put any number we want here that actually extends from number type, and this is what we call bounded type. We will see as we go on bounded generics. So this main class, our main class, is generic. Then what are the benefits of generics? The first is type safety. So if we come here and we try to put string, we are going to have a problem, because this main bounded type specifies that it can be a number or its subtype, but we are giving it a string. This is where type safety comes into play. Then we see that we eliminate typecasting, because we have bounded types, or we have specified a type. We don't need to do typecasting. Imagine if you're using object class, you need to typecast that object to the type that you want. Then we see that you can reuse code. As you saw with our main class, we were able to reuse it with different types. Then beginning with JDK 10, the keyword var cannot be used as a generic type parameter. So the compiler removes all generic type information, substituting the generic types. This process is called type erasure, which means that generic type information is removed from the bytecode. So the bytecode does not have generics. It should be clear that generic type is used by the compiler and is not available at runtime. And what is the benefit or the purpose for this? It is for backward compatibility, so that the bytecode is not contaminated in a way that code before generics will not work. So also it is important to know that generics only work with reference type. So you cannot, we saw that if we put an integer here, this works. You cannot put int primitive here. So generics only work with reference type, not primitive types. So if you say main long and main float, this will not be represented by different class files generated at runtime. We can demo this as well. As you can see, I can just come here. So I already have a class here. We see this class t extends number. So if we have main integer and main long, so what I can do, I can just delete this class file. What I'm going to do here, I'm just going to run this main. Sorry. So I've compiled main. So if I run Java P, which is you are decompiling it, we see we have compiled it with this code. We don't get different class files for the generic type information we have passed. As you can see, we still get it like this. That is what we mean by you don't have separate class files for the usages of your class. You still have one class file at the end of the day. So important to note, I've already mentioned that beginning with JDK 10, var cannot be used as a generic type parameter. We can just see that as well. If I come here, okay, I want to see, I can say, I want to say list. Wow, I cannot do this. This is not allowed. This is not allowed. And then also, today almost all code you work with contain generics. So it's important to write generic code to learn them thoroughly. The only way you can learn how to write generic code is if you work with generics code. You write generic code all the time. So generics help you to write safe code. We saw that it gives you type safety, which means your code will not compile if you violate the rules for generic code. So bounded types. There might be a requirement to have a parameter limited to a certain types. In this case, the parameter becomes bounded. So as we already saw, if you say T extends superclass, this implies that T can only be replaced by superclass or subclasses of superclass. And superclass defines an inclusive upper limit, which means that superclass also would be allowed. So for instance, if we come here, we are allowed to say main number main. This is totally allowed because this is inclusive. So class next T extends num. So as we saw that this means that number is inclusive, and anything that extends number can be replaced here when you're working with this class. Again, an interface can be used together with a class as a boundary. Multiple interfaces can be specified, or a class and one or more interfaces. A class must always be the first to be specified if you are actually combining it with interfaces, as we see here. So if we say class next T extends number and implement serializable, this is the meaning of this generic type information. So if I come here, I can say and serializable, which actually means that whatever you pass here must extend number class and must implement serializable. So if I was to, this number is an abstract class, so we see that it automatically implements serializable, which will defeat the purpose of what I wanted to do. Okay, let's say I have class B, for instance, and this class B, we have another class C. This class extends B. So if I say I put C here, and it must extend B, and implement serializable. So that means if I put C here, our code will not work. Why does it not work? Because C, although it extends B, which is the first rule, it does not implement serializable. So if I was to add implement serializable, now our code will work, because now C satisfies both conditions. So we see that if a class appears, it must be specified first. So let's go back to the code and say, and put serializable, then put class B. We see that this is an error. A class must always be specified first. That's one of the rules of generic. And also we saw that we can only have one class. You cannot have two classes here, because if you have two classes, it would mean that your class extends from two classes, which is not possible in Java, because that is multiple inheritance, which leads to diamond problem, and that is not allowed. So now we have what we call wildcards with generics. So the question mark is known as the wildcard in generics, and it represents an unknown type. The wildcard can be used as the type of a parameter, field, or local variable, sometimes as a return type. But class level generics can use a wildcard. So what this means is that you cannot have, let me just remove this. You cannot have something like this. This is not allowed. You cannot use wildcards at class level. So wildcards are divided into some categories. We have bounded wildcards. So a wildcard argument can be bounded in much the same way that a type parameter can be bounded, as we saw. Important for generic type that will work on a hierarchy. This is important for generic type that will work on a hierarchy. For instance, we see here, we have animal, then we have anything that extends cat. Anything that extends cat. This is what we have here. So this means that any class that is cat or derives from cat can actually be passed here on this bounded wildcard. So if I was to demonstrate this with a list, I'm going to remove this for now and work on list. So if I say list extends number, what I mean here is that my list is going to be a list of anything that is a number or is a subclass of number. That is the meaning of this statement here. Or you can even have super, which means that anything that is a number or a super type of number. So a method can be generated by making use of type parameter defined by the enclosing class. A method can use its own type parameter. A method can be generic inside a non-generic class. So what we mean is that if I was to demonstrate this, as we can see, this class is not generic. We can have a method here, public. Let's say it returns an integer, int. Then we have get, for instance. Then we have this as a receiving type parameter. And then what we have here, we specify the type that we are having. Then what we do, we can say, okay, this T can be anything. So for now, I don't want to do anything special. Okay, let me not return an int. Let me just make it void for now, for the purpose of demonstration. So basically I can say new main, I'm just going to create it on the fly, dot get, then I can pass anything here because T can be anything. Then I can run this code, 8 will be printed. I can pass string here, Java, I run this code, anything can be printed. But I can also make this type parameter to be bounded, in which case now I can say, okay, it extends number. Now I'm actually putting some rules. Anything that is not a number will not be allowed. So if I put 89, this should work. Also, I can make this method to be static, such that I don't require an object. I can say static. Then I can just say, I can just call it like this. Or if I'm not in this class, I will have to say main.get. Then I should still be able to use this class. This is what we mean by a method can be generic without an enclosing class being generic. Then also a constructor can be generic without an enclosing class being generic. So let's come here, we can have our constructor main. Okay, let's say main t, and then we are going to define a parameter here, that t. So for this demonstration, what I'm gonna do, I'm gonna add a number here, let's say number h. Then what I would want to do here, I can say extends number, t extends number. Then I can say h equals to t, because I know that t extends number. Then what I can do, I can just have another method here. This method can actually return this h here that we have number. So the return type, I'm gonna say number, and that I'm just gonna return h. Sorry, h. So now if I say, sorry, okay, let me not make it return, let me make it void for now. If I say new main and then dot get, oh, this should not be a get, it should be print. I'm just gonna say print because I'm not returning anything. I can pass anything that is of a number and it will be printed out for me from a construct. And then I can even pass a long, I can pass a float, this will work. I can make this to be anything, in which case I remove this type parameter, but this won't work out. That would mean now I have to make my parameter to be object. And it means now I can pass anything I want on this method, even anything. So we have other illustrations of declaring type parameters. So if we have class T extends B and C and D, in this scenario, B must be a class or interface. That's fine. We already established that. C and D can only be interfaces, since a class should always be the first in the listing. So if we were to demonstrate this, I'm just gonna take this quickly and put it here for us. So we have B, we have C, we have D. So we mentioned that B can only be a class. If we have, let's say, interface D, this is fine. But C is a problem because now you have two classes. So what we need to do is we need to remove this and now make this to be an interface. Then our code will work. Because now we can a class can only derive from one class. This should always be interfaces. That's the one version. But if you say T extends V, then you say comma B, comma C, comma, this means something else now. No, in this case, T, B, C, and D are generic types, but V must be a class or interface. All right, so let me show you this quickly. If we have this and we have this scenario, we said that V must be a class that exists. These ones, they may not exist as such. So I can actually do this to show you that this is the case. So if I put V here, this should work. But the other ones are type parameters. So that, which implies now I can have something like main. So we say T must, the first parameter in the list, type parameter must be of type V. So I should put V here. The other ones, we don't care. It can be anything. It can be string, it can be string, it can be integer. This will work. We don't care what it, we don't specify any type bound or anything. It can be anything. And then you have another scenario where you have T extends V, B extends K, comma C. So this one is another different scenario. So what this means is that T, B, C, D are generic types, but V and K must be either a class or interface. So if I was to take this guy here, then I am replacing it here. It means now V must be a class and K must be a class. So now what I need to do is I need to say class, or I can say interface. Doesn't necessarily need to be a class. Interface K, this will work. Now this means that now here I will have to have K first. Then the other two we don't care. They can be anything. So once you use extends or super, or let's say we use super. Once you use this, that would mean that now whatever that comes after it must either be a class or interface that exists in your code, as we can see here. Then we can have a situation whereby a class just contains parameters like that. So in that case, it means now this can be anything. We don't really care. We don't really care about the type. We can pass anything. As you see, we pass k, v, can even remove this and pass object, and you can also pass maybe callable. You can pass anything you want to pass here. It doesn't really matter. See that callable is can even do this. You are allowed, because you can put anything here. We don't really care about what you put. So that is all about these different flavors of type of the types that you can put for your class. So now, if you have this kind of code, list, and then you say bounded, you say wildcard, super, and then you have IO exception, and then you have new array list exception. What this means is that it's a list of IO exception or anything that is a super type of IO exception. And because exception here is a super type, this is correct. This is fine. But if you have extends and you put IO exception, and then you have exception here, this is going to be an issue. Because IO whatever that should be here must extend from exception. So let's see what we mean. So if we take this code and then we put it here, I'm just gonna copy it just like this, super. Let me import this quickly. So this is fine. Why? Because we are saying list of IO exception or its super type. So that means the range that we are talking about here can be, if you say list of IO exception list, this is still valid for this particular definition. Or you can say list of IO exception, because of the word super, this is still valid. But now if you say extends, you say list of anything that extends from IO exception. Anything that extends from IO exception. Exception class does not extend from IO exception. This is where the problem comes in. So for this to work, we can include things like file not found exception, and other subclasses of IO exception. Or you can put IO exception itself. This should work fine for your code. So these are some of the things for those that want to write OCP, they should be aware of. Then we have so assuming that we have list wildcard extends number ext, or you can put anything you want, equals to new array list, and we try to add 9 to that list. Although 9 is a number, the code does not compile, because if we have list of long, we cannot add 9d, which is a double number or a float, to the list. But the syntax of this bound means that we can add anything here that is a number. But now, when we try to add 9, this does not work. And the reason is that if it means this, the interpretation can be, let me just take this code and put it in the IDE for you. If we have this scenario, the interpretation can be list of integer. That's the interpretation. This actually falls within the bound specified here. We can also have list of double. This falls within the bound specified here. So now you see there is a problem there, because now I can also have my own number. I can have say class, I can put my name here, extends number. Then I implement all the methods that I need to implement. Then here, if I say list of, this also falls within this range, because this Motusi class extends from num. So now you see there is a problem there. Remember that at this point, the compiler, the only information it knows that whatever that can come in here is a number. That's the only information it knows. But now, because of type erasure, this should be substituted by something at some point. So now if it's substituted by double the type erasure, then we have list equals to new array list. You see that we cannot say list dot add number, add 9, because 9 is not a double. You will need to do this for this code to work. This is why this code is not working for adding this into this code. And now, but if you add null, this one will work. And the reason for it to work is because null can be anything. Actually means anything, nothing. Let me just put it like this. It means nothing. You can, an object, and any object can point to null. That's why it's working. So now comes a notion that upper bounded generic list is always immutable. Upper bounded because we have extends number. That means we have an upper bound in this list or the range, and the upper bound is number, and there is nothing above number. It can be anything that extends number. That means we have an upper bound. Anything that goes below number is allowed. Below number, I mean extends number. As we saw here, that I also added my own number here, and then I overrode all the methods that needed to be overridden. So this is why this is not working. So upper bounded generics list are immutable. So so now we have types of wildcard. You already had me mentioning upper bound. We have unbounded wildcards. We have bounded upper bounded wildcards, which falls under bounded. Then we have lower bounded wildcards, which also falls under bounded. We already saw that upper bounded generics, or what you can say upper bounded wildcard, they are immutable. Or you can say upper bounded generic list is immutable. And we also saw that unbounded, they are also immutable for the same reason. And we also see that lower bound, we see that lower bounded, they are mutable. So upper bounded, this is what we call unbounded wildcard. So if you say list of wildcard list equals to new array list, this actually is a wildcard, and it means a list of unknown. And with this is also immutable. You cannot add anything here. You can only add null to this list. If I say list, but you cannot add new object. This is not allowed. So and this is unbounded. So we see that upper bounded generic list is immutable. We also see that unbounded generic list is immutable. Then let's proceed. We have upper bounded. We already saw the upper bounded where we say list extends, and to declare an upper bounded wildcard, use the wildcard character followed by the extends keyword followed by its upper bound. Note that in this context, extends is used in a general sense to mean either extends, as in classes, or implements, as in interfaces. So we already demonstrated this. Then we have lower bounded wildcard, which means now you say list, a wildcard super integer. List equals to new array list. So a lower bounded wildcard restricts the unknown type to specific type or the super type of that type, but the upper bounded to a specific types or the subclass of that type. So we see that it's the same thing, except that now we are using the super keyword, and we see that this will restrict the list to its type or its super type. In this case would be super type of integer. So let's demonstrate this to see that lower bounded generics are actually mutable. So if I do this, I can say list dot add 9. So this actually works. List dot add 9, and this works as opposed to the other one. This will work because, assuming that we have, actually this means that we can have integer or its super type. So we can basically have something like list integer. This still fall within the range. Or you can have list number. This still falls within the range. Or you can have list object. This is still falling within the boundary specified here. So we see that for all these things, this statement will always be valid. But if we say extends, this statement will only be valid for this statement, but for the other two, it won't be valid. That's what makes lower bounded and upper bounded generics different. With super, all of this fit into this specification. But with extends, the only one fits. This one fits. These ones do not fit. This is why this will always work for lower bounded generics. So raw types and legacy code. A class or interface that accepts generics but used without type parameter are being used as raw types. Support for generics did not exist before JDK5. It was necessary to allow for backward compatibility. That is, pre-generics code should work well with generic code and vice versa. And the recommendation is not to use raw types after JDK 5. So how can raw types be seen? So if you have this kind of a code, list equals to new array list, you're actually using raw types because you are using generic code in a non-generic way. And a compiler does not have enough information to perform type checking necessary to ensure type safety and all that. And this is raw types. And it will complain, you will have some warnings in your code. So if I was to come here and have this code, you see that you have some warnings. There is a way for you to remove this warning. You can use what we have here at suppress warning to remove the warning messages. You can apply them here if you want. Okay, it's warnings, not warning. So if you say raw types, this will solve your problem. You can apply it at the local variable level. You can apply it at method level, or you can apply it at class level. This will still work. The reason for that is that this annotation does not specify the scope. So that means by default you can use it on anywhere you want to use it. If you do not want to use raw types, you can also use all, which means all warnings should be ignored. So this is actually used to ignore some warnings, so that when you're compiling code, you're running it, the IDE, or maybe if you're using SonarQube or other things, they don't complain to you. So even in this case here, so if we remove raw types here, and then we use our own code here, main, because we see that our main class, main, is also generic. So I'm just gonna do this quickly. I'm just gonna remove this. So if we say main equals to new main, and then we put this, so we see that we still have a problem here. There's another warning here. So if you want to remove any warning that can possibly come, you will have to use all, then it will disappear. That's the whole purpose of the suppress warning. So if you want to learn more about generics, there's an article I have on LinkedIn. I will leave the link below so that you can go and follow that link to read more on generics. Thank you.